Okay. All right. So welcome to another a Heretics Unified or Unified Heretics, and we're already full at it, even though we've only just got, we've only started the video. Okay. So I wanted to show you guys something here. We're talking about redshift. And I've got a share screen up at the moment, and I'm going to change that now to another screen. Okay, get rid of this for now. We can look at that one later on. Many movies.
Well, I was just looking at that image there you had, Stephen, about how you're portraying it as each cube is a reference frame in space with so many protons per unit over a distance, which is sort of how the mainstream would interpret Einstein, right? As the further out you look, you're going back in time because the shift of V equals m squared and all that jazz, right? It's all
right.
So I'm looking. My question, just to the general public, is: where is there an experiment or a proof that when you zoom with an optical instrument, that you're actually shifting time rather than just receiving light information at your time in space? Right? Why is it that they think that when you zoom outward that you're looking backwards? That's right. So where is this? Right. So I'm looking for where is this mysterious time traveling telescope as the basis and premise of our assumptions, right? And then I can answer the questions. But you need where's the proof?
Yeah, I've always been, ever since I was a young man, I learned about redshift. There's just part of me that's always said, that's not right,
And then if you think of each, in that column of cubes, you have the protons per meter squared going back light years. And with each collision, there's an emission of a new photon. Right? According to the mainstream theory, every time two electrons or protons collide, there's a new photonic emission. Right? So that's a light emission. Right, so that's changed. And so what color is that? Like, how much is that photon shifted? Right, it's now being emitted from a new
that's one thing I've been looking at. Yeah, one of the things I couldn't figure out from all my searches is why red? Why redshift? What makes it red? And also, all I get is the explanation as to what redshift is, not why it's red. And I went and looked at collisions, what happens at high temperature, when two protons smash together in space. And I haven't found those papers yet, from 20 years ago. And what I was saying was they apparently create temperatures in the millions of degrees, and I presume they're figuring that out from a spectral analysis. I mean, I can't think of any other way they would do it.
Well, that's it, right? Like if the photons that you're receiving at your instrument in space are not the original photons emitted from the object, how can you verify and justify that you're now, because that's a different time. Right, the photons you're receiving now were emitted at a different time, supposedly. So how is it that the original image, you're going backwards and saying, well, this is the original image in time? You're not even seeing the same photons. Right, it's not even relative to itself.
I don't get, that's the part that instinctually I never got. Now that I've seen the James Webb Telescope images of fully fledged spiral galaxies with second generation stars in the what used to be called the Dark Ages. They haven't changed that yet, I bet.
It's like Jake said,
that's made me just completely lose faith in that whole I was sort of saying that I put on the back burner, and I've never really challenged myself to think about that anymore. It's just like, oh yeah, redshift. But now after this last 6 weeks, I'm like looking at this. I've got more questions for you guys than I have comments. I'm like,
it's like,
I'm sort of in a dark zone right now.
And as Jake was saying earlier, before we started recording, was with the analogy of the white TV screen with your static image and just random noise on the screen, right? If when you look up at the night sky and you see that there is color, there's stars, there's black, there's white, there's all kinds, like a myriad of imagery there, right? So if according to mainstream science that there is no interference in the path of a photon coming from one object in space because it's mostly vacuum. So the original photon is the one that's emitted from the object. That's what you're seeing. And there's nothing there to filter it, right? Then like Jake said, it should be a white sky. You should never see anything. When you look up, you shouldn't even see the sun, right? We should be immersed in whiteness and noise constantly, right? So there is something in the medium that is filtering the light, right? We're looking through a filter, a pass filter, a high definition, high bandwidth filter, right? And we're receiving it now.
Yeah,
So
and the other thing with Jakob's comment about all white, I'm wondering if you know, when you have a collision, excuse me, when you have a collision of molecules at high speed, you know, there has to be absorption as well that must occur.
Mm-hmm.
So you get, would that create the speckled look?
Well,
For sure.
it's back to the whole point of what is the nature of the medium and how transparent is space. And the whole thing, to me at least, starts breaking down a little bit, because it's, when you're looking back in time, so to speak, as that's basically what's being claimed, right? And of course it is a factual thing, but
Yeah,
the time of travel is dynamic, right? So it's not like the evolution of the universe just goes on pause for your sake. So it will be more and more dense, and I'm not seeing that increased density and reduced space, which is then takes us back to the whole inflation thing, that they're not really talking about a Genesis model. They're talking about a snap of the finger. It is not a developing universe. And now with the way too early galaxies, it's even worse now, right? It's like this thing just pops into existence way too fast.
Yeah, they're way too early. They're way too small. Like they're not, right. So there's no expansion being shown according to inverse square law. As the further out you look, the bigger stuff should look, and that's not happening at all. It's actually the inverse of that. Right?
yeah, that's
So
going into the wastebasket.
Right. So now they're trying to change it as far as, oh, well, we're going to change the expansion rates and scales and blah blah blah. Well, why not just accept perspective? Right. You're looking at perspective. The further back, further away you look, the smaller stuff gets. It's that simple. Right.
Yeah, that's what I've been, from what I'm gathering, and do correct me if I'm wrong, because I'm just sort of part of this I'm really grappling with. According to the Big Bang model, as you go back in time, the galaxies actually start getting larger. And that was one of the proofs of the Big Bang model, because they were using the Hubble telescope, and it sort of was giving them that impression. But as they're looking at these galaxies in the dark age, they're actually smaller, as they should be, in terms of the perspective in old times idea of perspective. So that
see, and the Hubble, if you compare the data between Hubble and the JWST, right, it's different, right? So basically, Hubble had bad eyesight, right? We gave it glasses and created JWST, corrected vision. That's all we did.
I just think, to me, again, back to what is the alternative, right? Right. If the alternative is something to do with the nature of space and the curvature, and that there is an almost a limit to which is okay, this becomes a little bit based on math. But think of the age of the universe like the line of sight of a horizon, right? So the current line of sight on an earthbound spherical thing is about 21 kilometers at around 2 meters, right? Or about a meter and a half, 2 meters. Your sight line straight to the edge is going to be 21 kilometers. I think this is very similar. And this is also why it feels like things just pop into existence, right? It's because if you had a fleet hiding at 23 kilometers range, right, from the coast, you cannot see it. It is only once it passes the 21-kilometer line that it almost magically pops into existence. And I do think that this is very similar on a 4D/5D type of universe. The edge is the same curvature thing that you're seeing. So you will never see what's on the other side of that 13.4 or 14 billion light years of range. That's literally our horizon.
I think what has happened with the James Webb Telescope is the barrier, give me a miracle and I can explain the rest barrier is kind of gone. It doesn't mean that there's not a maybe we're in a huge cell. It's just that now we know that it's probably much bigger than we thought it was. If we're seeing galaxies like the ones, garden variety galaxies over there, that we're seeing here, I mean, you could just basically say, well, they're just disappearing into the event horizon fog. And hey, buddy, that's as much as we'll, unless we get new instruments that can look further into that event, think of a London fog, right? And you see you can see the bright lights going down the road, maybe 3 of them on the highway, but the 4th and 5th and 6th ones you can't see because it's a pea super and you can't put a hand in front of you.
But
you
Stephen,
just barely
you have to
see
stop yourself. You have to stop yourself because more tools will not help you if it's a curvature.
No,
nothing is going to make you able to look beyond this weird higher dimensional curvature of the entire universe. This is your horizon.
Jakob, you're going for higher questions. You're going for much higher questions than I am.
Well, the point is that you can have binoculars at any strength, right? Any type of tool available, you will never be able to see on the other side of a curvature of the universe. You're going to be able to see 20. You're going to be able to see 21 kilometers because that is literally the physical limitation of how far out at sea you can see anything.
Yeah, that's the 4th light on the highway. You can't see any further because of the fog. Yeah. But
no, it's not a fog. It's not even a fog. It's a curvature. So
you call that a curvature. I call it a fog. But they both mean the same.
Because a fog you can watch. You can see through a fog.
No, you can't.
Then you just need better. You just need better tools, or you need, or you have to process the images better and stuff like that. You can see through a fog. That's not a problem because that's still in a straight line. But your straight line will not help you with curvature.
So just to steelman that a bit, Jake, if I could steelman that and then kind of reiterate what Steve was saying there. So if we look in detail at the image behind Stephen's head, right, and you see that toroidal shape where the galaxies are being warped, right? You can see that
lensing,
the lensing effect, right? So to kind of reverse what you just said is if you put yourself in the perspective of someone inside of one of those warped galaxies that we see being warped, right, and you're in that trying to look outwardly, the path of your observing is going to follow that curvature of this toroidal magnetic field that's being warped, and you're not going to see beyond that, right? That's all. Everything you see is coming through that EM filter that's being warped and focused to your focal point, right, from your perspective, right? So,
and thus, I'm not disagreeing with Jakob. I'm just saying, okay, I'm going to work within those limitations. The larger philosophy of the of how and why. I'm going to leave alone in this instance because this is something that I'm curious about. I want to know in that containment that I know that you find appalling, Jakob.
But think about it. It would actually give us an idea of visualizing the universe anew. Because if it's a curvature, right, it should be able to tell us something about the potential scale of the universe. How if you could time that, right, you would be able to say, well, if it curves that much in 14 billion years, then how much theoretically is it on the other side of that horizon?
Have they been able to measure this curvature?
Well, I don't know. See, I don't think. Well, that's the thing. I think it's going to be more toroidal and more like a Mobius strip kind of an effect. It's all electromagnetic, so I don't think you're going to find a nice smooth spherical curvature with a constant radius. It's going to be variable.
That's going to be a question, I think, about analyzing what it is that we're seeing on the distribution on the entire background in all directions, right? They say that it's fairly uniform, but of course it's not entirely uniform. It has fluctuations, and then we should be able to say something about what 4-dimensional, 5-dimensional shape is the universe that would make this cosmic background radiation, basically this kind of horizon. There's some fascinating things about I think I told you this about things like minimal surfaces. When you do
manifolds,
when you do there's some funny visuals made with minimal surface eggs. So you have egg shapes, and then what is the minimal surface of an egg shape? And it looks very organic, almost like a mushroom. Fun fact, we're back to the biomimicry. But the point is, if the universe is distributed similarly, right, which is fairly valid to say, the universe would do something that is minimal surface based. It's not going to try to make anything spherical if spherical is not the minimal surface.
Right. Yeah, it's going to be asymmetrical fractal, right?
Exactly.
It's trying to seek the least action, least potential, and least path, right? Least energy. Right? It's always trying to conserve energy, even though there's loss of time.
I got a question for you guys.
Right?
Is that this curvature of which you speak, is this a known quantity?
Well, yeah, it's supposed to be according to Einstein theory. Curvature of space-time is a constant relative to the speed of light, right?
So there's actual numbers that could be used to determine what Jakob is looking for.
I'm sure we could go looking for it. I'm sure it's out there somewhere. I'm not sure exactly where to look at this moment.
Let me just show you an example here.
Well, that's maybe something we should pursue because
well,
I know
the thing for me. Well, the thing for me that debunks that kind of an idea is Einstein. I'm talking about here is going back to the image behind your head again. Is we can see that the lensing is not spherical, right? It's actually toroidal. You can see how it's lensing the galaxies in strange shapes. Then there's all kinds of images from NASA that show like there's a happy face one that looks like it's being warped into a happy face. And according to mainstream, that's supposed to be a single point gravitational point of lensing, right? So if you follow Einstein's equations, all lenses should be rings and spheres. You should see Einstein rings, like so when we look up the night sky, you should see halos everywhere, right? And we don't see that. There's no symmetry there at all. It's all toroidal and filaments and twisting. So when you're looking through a plasma nebula, you're getting lensing. Like when you guys have seen that experiment when you apply a magnetic field to an oil that has a light shining through it, and you switch the magnets on and off, it deviates the light, right? So I think a lot of what we're seeing is that we're seeing distortions through electromagnetically active gas fields.
Right. That's with the electric universe, I've seen them talk about the lensing effect being an optical rather than a gravitational. Again, I don't know a lot about I mean, it's important if it's one or the other. So the question is, in the electric universe, optical argument, are you seeing galaxies magnified through these distortions?
We're seeing Dr. Dowdy, I believe is his last name. I think he's passed away now. And he was NASA doctor, physicist, and he showed that the only lensing we're observing is at the limbs around stars and so forth, right? So as light passes through the corona, right, and through the plasma medium, it does do that lensing, but it's only local to the star. It's not relative to the gravity field. It's only at the just as it skims the surface, right?
So do you think
Which makes sense.
is this an either or do you think these are two different phenomena that can exist in space?
I think it's an either or. I think it's basically back to the nature of the universe, that it's doing things in this scalar way. So if you're talking about this lensing or these gravity effects, it's actually when it's moving from one area of space into another, but it's very, very distinctly demarcated. Right.
Yeah, the lensing the Dr. Dowdy's showing.
It's the surface of the sun. It's the edge of the the galaxy. It's the edge of these pockets that I just tried to illustrate with the eggs and minimal surfaces. The space and the material in space is going to be collected in these minimal surface boundary conditions, and it's when they're moving from one to the other. When it's moving through this, it basically behaves exactly like it's moving through a lens. But when you look at this at massive distances, this looks like an average. So you're not seeing all the little lens effects.
Yeah, you're seeing aberration and filtering. And, yeah. Can you go back and show us the eggs there again? I wanted to see it.
Yeah,
I kind of interrupted you there. Apologies for that. I cut off your train of thought there. But
you can make that with a 3D printer.
Yes. Mm-hmm. The point is that this is the topographical minimal surface distributions that are possible, right? It's what everything does, whether you're playing with foams or non-Newtonian fluids or whatever you're working with. It wants to do this, and then of course you can start talking about details like surface tension and whatnot. But that's really just minor mechanics. The fact is that the universe always wants to do this. It does not do straight lines. It does not do perfect spheres. Then of course sometimes it kind of does, but that's at a certain set of conditions it will do perfect spheres. Otherwise it will try to do the actual minimal surface. And this is why the shape of things like the universe is most likely, once you start scaling up, it becomes more and more like this. But if you go back just, I'd say 30 years, our understanding of things like this, fractal nature of space and minimal surfaces and foams and liquids and all that, it was really limited. And we did not have the computational power to even start looking at it in a serious way.
Yeah, I definitely think that, Z is equal to, Z squared plus C, right? I think that formula actually trumps E equals MC squared.
Yep.
Right out of the gate, right?
And if I'm not mistaken,
it occurs to me, if you took those eggs that you were showing them, if you took the event horizon away and you could see further, as you look through space, there'll be more and more of these lens effects or optical distortions until all there is the distortions, much like that egg shape that you were showing,
and
Jakob.
this is why you have to go back and ask some of the fundamental questions that we had no way of answering 50 years ago. Like, anyone that's ever looked in a kaleidoscope, right?
I was just going to say kaleidoscope.
And played with optics like this. It's like, what would the universe look like if it was more shaped like this? What would our view out of our spaceship actually be, right? Is it possible that a lot of these things are basically a lot of weird lensing effects, and the fact that the scale and size of the universe is so large? Chris said, what if it's donut shaped? Well, this is the kind of question. What would the universe look like if you were looking out of the window into a donut-shaped universe, or whatever, right? You will get these kaleidoscopes effects. You will get these weird. It could be that you're almost watching the same universe at different times from different sides.
I was going to say, what if what you're looking at is actually a reflection of yourself to infinity?
Exactly.
Right.
Anyone that's ever been in a carnival in the Hall of Mirrors and stuff like that,
Right.
or watched the Bruce Lee movie
Enter the Dragon, was it?
yeah, Into the Dragon, where he's like seeing himself reflected, and you get all these things. I think we need to consider what is the alternatives, and we did not have, Einstein did not have any way of imagining things like this when he thought up these things. None of the big guys had those abilities. It's something completely new, so we need to revisit it. I think was it Petrov that was just talking about superfluidity and Bose-Einstein condensates and the quantum fluctuations and behaviors that might actually also be at play in singularities in black holes. Again, I don't think that, well, I don't think that black holes is exactly what the current models are saying. I think we've touched upon this, but some of these behaviors and some of these fluctuations are exactly in the direction that we've talked about, right? The universe is doing things that we could not model 50 years ago. These micro vortices that are not really vortices, but still they kind of are. This is exactly back to why we need to seriously revisit things like fractals, things like cymatics, talk about these macro patterns and their fractal behavior, because this is going to show us exactly why you get something that looks slightly ordered when it's on the scale of something like an experiment with a Bose-Einstein condensate. It's fine, it looks nice, but this is back to 500 BC, right? When Plato was playing with his platonic solids and his nested solids and all that stuff. What does that do? And what happens when you start scaling that up? I know that I keep almost repeating myself, but we need to think more like this, because you hear the scientists are more and more talking about similarities with things like how water behaves, how vortices behave, and all that stuff, even though they're talking about a Bose-Einstein condensate, a quantum state, right? So, and maybe we also need to completely revisit the whole terminology of what is quantum. This is what some of the guys that are looking at things like the pilot wave, and again, we go back into the whole ether or subspace and the nature of the medium.
Well, I agree, Jake. That's where I think mainstream really went wrong, is when we started quantizing electrical phenomena, whether we, quantizing of a photon or the quantization of electron charge, or right, I think that's really where we jumped off the rails. It's thrown a big monkey wrench in it, because we've then lost the effect of the medium itself on the propagation speeds of frequencies.
Yeah, and I think,
for example, I can share you. Maybe I'll share a little video. Maybe you guys can check it later on.
Well, he's looking for that. But it also reminds me of fungal intelligence. The flow effects that you see in what the behavior of funguses looking for food, and
bacteria,
then you draw
bacteria and stuff. With
ants.
Bacteria,
doing the same thing.
Yeah, I was watching
about it. It's important that when you say something like that, like fungal intelligence, then you're back to the fractal nature of things, right? Because what is it that makes something seem intelligent? It is the fact that it is retroactively self-referential. That is basically what intelligence is. It's that I perceive the universe, and the perception affects my action, which gives you this weird wobble in space-time, really, right? I am able to throw my mind into the future. Well, is a fungal able to do that? Well, we could discuss the nature of it, but the fact is, because it's self-referential, it can know in advance what the correct path is. Maybe even something like lightning is showing a behavior that is intelligent. When it's trying to branch its way to the slowest and least resistance path towards the ground, it does a very similar thing to the fungus, to intelligence.
Yeah, that bifurcation effect relative to charge
Yeah,
density in the
I-
medium, right? It's like the bacteria or the lightning. You can either one, right? They meets a certain level of resistance, and it says I can't go any further, so I need a new lease path, and it bifurcates and chooses two more paths, right? And that keeps, that's the same as like the forward propagation of cosmic radiation coming in, that cascade effect, right? You get a high energy particle coming in from space, hits the atmosphere and goes, right, and just spreads in this bifurcation effect.
And this
Chris,
feels like,
Chris,
or
I have
this,
your link ready to go. The why does water change the speed of electricity? It's 24 minutes long. Is there some part of it that you'd like to show us?
Can I just interject with one thing? Because what is important when we're talking about something like random walking and bifurcation and lightning finding its path, or fungus finding the optimal route, the important thing here is that to us as observers after the fact, it looks like it knew in advance. It looks like it's quantum guessing.
Right.
Yeah.
Right. It's not going and testing all the paths. It automatically seems to know which one is the correct one. And when you analyze it after the fact, it looks like it's got precognition.
Right. It makes a choice based on the constraints within itself. Right. It's constrained relative to the field that it's in. And this experiment here kind of shows it. If you skip to 15 minutes and 55 seconds and maybe play a couple of minutes or something.
Before we do that, just to illustrate what we're talking about right now, this is only 2 minutes long, and I was showing it in Science Tech Nature. Actually, I didn't come up with this one. It was one of the other members. Let me show you this real quick.
So if we agree that the fractal field
one
is
classic
actually
example
determining
the
form.
Japanese are so clever at this. They there's a slime mold, called Physarum polycephalum, and they had and this slime mold is very, very good at navigating through mazes and challenges. I mean, first to food wins. The conservation of energy, is rewarded. So you don't
how
want
do they set this up? They put a little bit of it.
They did several experiments. The most fun one is they designed a nutrient, basically a nutrient-like maze, replicating Tokyo in the Japanese subway system. And so they started with Tokyo, and they put oats, which is a nutritional source. They inoculated what is on this basically an agar map with all the major cities, the nodes around Tokyo, and they then makes each of those nodes had a piece of oat on them, which was a source of nutrition. The main oat was where Tokyo was. They inoculated it, and then they let the slime mold then grow. And first it grew out randomly, exploratorily, just like you would do if you're a hunter or something. You're hunting on the landscape looking for things. And then after about 28 hours, it reorganized itself in the most efficient way possible and reorganized the Japanese subway system in a more efficient manner than it's designed today.
And again, as you can see, it seems as if it's doing this with precognition knowledge. It's bifurcating and finding the optimal route as if it already knows the whole map. And this is back to maybe it's because it actually does. Maybe it's because that information is fundamentally unavailable information in the universe as ambient information. I know that takes us into something that's a little bit woo, but
that sounds pretty reasonable.
Start using things like akashic fields and stuff like that. But it's really the fact that if you have a system where everything has these locations, then any part of reality is going to be influenced by that. So the fact that you start building roads or pathways or neurons, it doesn't matter. The shape, like, okay, the shape of your dome, right? Your brain, your brain box, right? This is limited, right? What is the optimal surface that can fit into that. And then you're back to the minimal surfaces thing, right? And how do you fill what is it? What should we say? 3-4 cubic decimeters or something like that. Well, the CC is on the internet. The actual compartment size. Then you have to now wrap a football field of surface into that. So it's like when you're playing with your sheets and you're crumbling them, or you're trying to put your sleeping bag in another bag, right?
Holding
like
DNA.
Well, yeah, that too. But this more like a surface. DNA is strings and they're curled up, and it's more like twisting rope. But the point is that the edge of your skull is going to decide the shape of everything in it. There's not like a massive infinite amount of ways you can do it. It's a fairly fixed way. And then it's back to the fact that the way that the dome of your skull actually grows, it's back to the fact that these two systems are feeding into each other, right?
Yeah,
the growing of your brain and the growing of your of the box. Those two things are tied together.
Yeah, two things I'd like to just bring up is one is that the fungal intelligence that we've just looked at. I found two other longer documentaries that then talk about how fungal behavior mimics the fractal behavior as well, and also what's that called when fractals grow? What is that? The guy who came up with that, growing fractals.
Mandelbrot?
Yeah, the Mandelbrot. They say that there's a direct link between fungal growth and Mandelbrot behavior. So that was one thing I wanted to just throw out there. And the other one was, well, hang on. And the other one I wanted to throw out there was this possibly two kinds of, there's intelligence, and this fungal would be intelligence, but there's also, I think, is there also sentience, which is an overlay of intelligence, or are they? Does intelligence not exist? Is sentience doesn't exist? Is that just part of?
It's an effect
of the intelligence.
Can I just take you back to the lightning, right? So the system where a lightning bolt is striking from one location to another, the medium in between is kind of fixed. It's unknown, but it's fixed. That means that basically your ground is becoming what Terence McKenna calls the singularity, the strange attractor at the end of time, right? I know that sounds like I'm going a little bit woo, but the point is, from point A to point B, that is a set thing. So if you push that into time, what happens is that there is only one outcome. So it is actually the ground that is telling the sky how he is back.
Jakob, Chris, are you seeing Jakob freeze up?
It's why they keep saying, right, but it's because it is not just at the source, it's also at the destination.
Yeah,
Chris might follow my way
of thinking. For every source, there must be a sequence vice versa.
And what does that teach us?
Well, it teaches us that the result, even though you're looking at your little petri dish, right, and you got your little maze, but the result might be in the future, but that doesn't matter because the system skips the whole thing of time. That is the result is the solution. So the solution in the future is telling the past, this is the way to go. I know it sounds very strange.
Yeah, so in that analogy, I guess time would be accumulated hysteresis in every atom that exists, right? Is that what you're saying?
I'm saying that anything that behaves in this fractal manner have the ability to behave as if it's intelligent, because it has access through time,
Mhm.
it acts back on itself. The self-referential nature basically creates these, it's almost like waves reverse in time.
Time reversed waves.
Yeah.
Yeah.
And-
Well, yeah,
and
that
this
makes
all-
sense. That makes sense to me. Time reversed waves is.
and it's
that's
very
Can we
different,
get back to a second to the link that Chris sent us? Was there some particular part of this that we could watch together? 1550. Okay, got it. All right, here we go. 1533. I'll start at 1533. Hang on. Get to screen share.
You'll sit in the electric field and cook for a while. It will eventually orient itself, like literally rotate the entire molecule to align with the electric field. So now let me come at this from the other end of the spectrum, quite literally. The index of refraction of water is about 1.33. That is the expected slowdown of light, like optical frequency radiation passing through water. So if we just predicted that water was going to slow down the propagation of electric field by 9x, but light, which is just an oscillating electric field, is only slowed down by 1.33x, what gives? Turns out that the slowdown that you expect is frequency dependent. So if you have that water molecule and you apply an electric field, that sort of slight rearrangement of the electron cloud, that happens like instantly, almost instantly, because the distances are so tiny and the amount of stuff that has to move is so tiny, that just happens. Next, the whole molecule starts to rotate, but that happens really, really slowly. Now, once that molecule rotates, it has a really significant impact on the field. Because of this, we can say that very, very high frequency electric fields, like light that you can see, is going to interact with water molecules very weakly. And very slow electric fields that are going to stay at one polarity for a really long time before flipping and gives the water molecule
And with there to manage that. Yeah. So anyway, since that didn't quite work out, I can kind of
Sorry about that. I get that sometimes it's science tech nature where it just crashes. So apparently we're still recording. And do you want me to continue with this, Chris?
No, that's okay. I'll try it. Since it didn't work, maybe you can edit it in there, a little clip of what he says, just to kind of back up what we're saying collectively, because what he's saying confirms what we're talking about, where the media, like, so he took a wire. I'll just condense the whole experiment. He took a wire and basically ran it down through a PVC pipe and filled it with water, and then timed how long it took for the frequency to pass through that 21 meter or 23 foot, whatever it was, wire. He did it in air, and then he did it in air at first and timed the path, and he did it with the wire surrounded by water and timed the path, and he got those differences, 1.33 to 1.89 per prediction, which is contradictory to the predictions, right?
So what do you see is the significance of this when you step back and look at it?
Well, he's showing that the medium that the wire is in, the water, right, is slowing down the path of propagation of electricity from the ether into the wire, right? So electricity is coming from outside of the environment into the wire and following the surface of the wire. And when you put water around and insulate the wire, it slows the path of propagation of electromagnetism out of space into the wire, right? There's no electrons flowing inside the pipe. Like the wire is not a pipe, right? Right. So that's the thing, is the environment is the condenser, and also we radiate light into the environment, so that, you know, space, because it's full, like you said, it's full of hydrogen and protons, and it's full of all this stuff that's, you know, presently electrically neutral, but still, as you try to pass that light and electromagnetism through it, that path is not constant, right? It's variable.
It fluctuates.
It's flux. That's why we see something, right? That is our lens. Like it's that slowing down and speeding up of light in variable, coming through that variable field, that allows us to see what we see when it comes through our atmosphere. Because our atmosphere is actually a filter, right? When you're in space, you can't see nothing, right? So, you know.
So when you think of it, really, everything is a filter.
Everything is a filter.
No
Yeah.
such thing as
Yeah.
pure.
No, there's not, right? So really it's like, and like we were saying before, every time a light wave, I'm going to try and stop using the word photon because I hate it, but every time a light wave hits a surface and bounces backwards the other way, it rotates 360 degrees or 180 degrees, right? And comes backwards in the opposite direction, right? So it's all light we see is polarized, right? That's the thing.
I've saved your link for my own my own research later on into my Facebook. Into my bookmarks, so I can
But it's
I can
back to-
watch that later in its entirety.
It's back to the importance of what is the reason for entanglement, and the reason of entanglement is basically the fact that time and space and matter and all of these things are all self-referential. The whole concept of entanglement is basically say, oh, it happened. It's because it knows. It's because it's entangled not just on the quantum level, macro level. That means that if you try to magically put in say you fire a rocket with a vapor trail at a cloud, you've interacted with it, right? Now you're forcing it to do something, and it's the same type of entanglement that you see in the quantum realm. When you change a particle that is self-referentially tied all the way back through time and space with an event, then it doesn't matter if you're doing this at a different time or a different space. It will still affect what it's entangled and referential to.
Yeah, it limits the information that has access to. Yeah, absolutely. Yeah.
So when you stop photon A and you see an effect on photon B, it's because it's all self-referential. It's all entangled. It's not just those two particles at the source of creation. That's a misunderstanding of what's going on.
Mm-hmm.
Because it's because we keep thinking of this like magically appearing billiard balls and solid particles. There is no such thing.
Right.
Back to why Chris does not like the term photon, but prefers light wave, because all of this is fields and waves that are self-referentially entangled. So what you're doing to photon A will affect photon B.
Can I just stop you guys for a
far
second? I'm hearing a background noise going on, and I just checked and see that there's no fourth person here. So are you, any of you catching that at all? Okay, all right. Yeah, no, I find the entire entanglement thing has left me completely gobsmacked. I look at that and I go, I do not know where this is going, but this sure is interesting stuff. And how it just speaks to the bonding of the universe in its entirety, and that's just an awful lot to take in, and I don't know where that leads, and if we will be making experiments that will further develop that. And even the fact that now they've done it to 20 miles, where they've done an entanglement. I mean, instantaneous, goodbye speed of light kind of thing. I mean, I just find that really absolutely jaw-dropping.
But again, it's back to the same phenomenon of entanglement, and to me, there is no difference whether you're doing the experiment with a random walking fungus, a random walking lightning bolt, or human consciousness. This is the same type of entanglement. It's just instead of being entangled in space, you're entangled in time. There is no difference. The universe does not care whether it's an entangled effect in time or space. Same
that's
thing.
That's very insightful.
Yeah, well, that's it, right? Like you can consider the back propagation of EMF as a time propagation in reverse, right? It's exactly the same. Yeah.
And it gives people headaches because it is weird to think like that. But because of the, I'm almost going to be inclined to say the holistic nature of the universe, as soon as you move up a scale, right? As soon as you move out of space and time by increasing the dimensionality, then what you're looking at, you might call it spook action at a distance, but it's not spooky at all. It's not spooky from the perspective of the universe. This is back to Mr. and Mrs. Flatlander. Yeah, to them it's weird that you can look inside the body, but it's not weird for us. And it's the same with the universe. It doesn't care whether it's space or time entangled.
Yeah, I think like when we published our paper there, and we showed that, you know, gravity is electromagnetism interfering with itself. Like Stephen, when you said the two particles come together and they collide and they emit a photon, and that energy is reduced just for an instantaneous second, there's a gravitational pulse there, right? You could call it that. But it's actually the negation and the collapse of energy being emitted and lost causes this implosion effect, which is shading. It's two particles are shading each other, right? And they come together because relative to the outside environment, the amount of energy between them is now reduced. The least path has been established, right? So we've reduced that to make the least, and they come together to collect, right? They condense,
I don't think of this. I think contemporary science thinks of this collision as an unorganized, as a Jakob is fun, who is just a big male-oriented Big Bang event occurring, and I think that it's possible that those collisions are highly organized, and that they create these momentary absences of space that in turn propagate the effect of gravity on the whole fabric of space.
And that's the thing, right? That so in our paper we showed that is the effect, right? So gravity is electromagnetism interfering with itself, but it's at the scale of the universe, because we set the radius of the equal to Planck, which is the radius of the entire universe to its edge and back in theory, right? And so when you do that, you end up with everything is coupled, right? Every atom, there's only one field, one electromagnetic field shared by every atom in the entire universe instantaneously, right? Everything is connected, right? So a change or a loss of energy in one area is going to cause an effect on every atom relative to everything else. But it's like you were saying with the fungi in the petri dish. I was watching, I don't know the documentary you were talking about, but I saw one I think similar where they had cells in a petri dish, and each of the bacterial cells would put out a pulse of energy, and you could see it. You
actually can.
Right? Right, and then when they pulsed, those waves, the waves of the 5 or 6 bacteria would cancel each other out, and all of them would move together closer, right? And then the next pulse, and then they move closer, and then the next pulse, right? So there's this pulse and cancellation cause and effect. It's like an oscillator. It's a spring balance. It's a spring. Right?
That's really interesting, Chris. You see that kind of pulsing in slow-mo or in delay movies where you see plants growing and stuff. And I know part of it is the sun and the cycle, but the pulsation thing. Has anybody done any deep research into those pulses and what they relate to? It must be, if you see something, grab it. Well, I'd be curious to see what
But this is the way that you get the effect that we're talking about, the entanglement effect. The way that you see things is a pulse-like nature.
Yeah, an oscillation.
It is the oscillation that gives you the sensation. So it's basically orienting itself based on that. This is back to when something is pushing in one direction, the reply is going to come back as a force in the opposite direction. This is going to give you the information. So you can think of this as, if you are able to create oscillations and pulses in space or in time as well, then the information that you get back is going to be able to make it possible for you to take the signal and create a new response, right? So it's almost like quantum seeing in the dark. It sounds weird, but it is the way that a fractal can behave sentient.
Yeah, it's like it shifts from being transparent to non-transparent, and transparent. It's like, okay, in out, right? And then they call that what do they call quantum entanglement or particle to particle, that kind of thing. But it's the same thing in two phases, right? That's the way I see it. It's amazing,
it seems that we've got general agreement that the entire universe is oscillations / pulsations. I think the only time there isn't, where there is continuity, is when there's absolutely nothing, and it doesn't last unless you contain it. It doesn't last very long, and I find that's sort of like, for me, because I can't do the experiment yet because I haven't found anybody to do it. But for me, that's the sort of like that's what I'm really curious about. The tear. Can we make a tear in this? Can we rip it?
I don't know. I don't think you could. I don't know. That's just my hunch. I don't know. It's just a guess. So I don't know.
And I think there's a flaw in thinking of like a tear. I think our problem is still the limitation of visualization of actions and interactions. I always come back to the problem with things like self-referentialism and entanglement is it's the scaling, right? So if you're just looking at one event, it's fine. But once you start looking at several events, like 2 or even 3, now you start getting real trouble, because this is very similar to, I think everyone that might be listening to this has seen the linked pendula, where, well, it's easy to have one, but as soon as you've got 2 or 3 pendula linked, you start getting chaotic behavior. But even that chaotic behavior must be governed by rules. It's just that our rules do not match the model. We do have some equations that can model something like linked pendula for a period of time and simulate it, but it still breaks down. This is back to the fact that we are limited in our knowledge and in our understanding of the self-referential nature. I know this is going to be a little bit woo, but it's very similar to, you could argue that when you look at the evolution of biological systems in a biosphere, that is also disconnected from time and is actually functioning with a strange attractor, that it is the result that pulls, it is not the past that pushes. So especially when you start looking at things like symbiotic relationships, how do they arise? How does something like a 3 species entangled symbiotic relationship actually arise? Well, it arises because there is this almost effect from the future. They are seeing the future before they are moving into the next generation. So the biosphere, or the biome that is the result of evolution, is already telling them what to do. That sounds weird, but it is the only really effective explanation. It's back to the random walking fungus. It's the same with random walking through evolution. Well, the future environment is already telling you which direction to go.
So basically biofeedback loops and evolution are time reverse waves, right? In information transfer.
Chris, this link you just sent us, I watched that on the last Tuesday. Someone sent it to us in Science Tech Nature. Fascinating, the self-sacrificing amoeba and how they develop and move. It's just absolutely like,
I queued it up. Well, I queued it up to a spot there where you play like 30 seconds of it. It'll show how it actually emulates galaxies, right? It makes galaxies.
Here we go.
Concentration. The other thing they do is they give off their own burst of signal, and this signal spreads to number of different aggregation centers. As nearly rejoin the stream and attach themselves to their neighbors. You can see them moving forward in a kind of rhythmic pulse. They are very much individuals though, and at this point they came across food, they would go their separate ways. As these streams come together, they break up into little blobs of around 100,000 cells, all swirling around, and then they do something remarkable. They start to sort themselves. Cells that are more malleable still that are just recently.
Yeah, that's probably enough for our purposes there, Steve.
I was thinking of the spot when they do that spiral. Let's see if I can find that part. That was just absolutely mind-boggling. Let me see if we go back a little bit, if it comes up, for Jakob's sake. There we go. That's really, let's watch that again.
But this takes us to again. It's the same topic, right? It's the direction of well, the arrow of time, and whether you're looking at positive spaces or negative spaces. Are you looking at something that is growing positively in time from a knob into a shape, or are you looking at, say, the dying of cells in the opposite direction? Well, directionality in time is in part an illusion. I think that's the most important thing to take away from this, and we need to start at least questioning our reality based on that. Like I think I've said this before, but when you have a growing fetus, right, and the genes are all igniting and all that stuff, we could go into very deep detail, but the whole thing is back to when the blob that is supposed to become a hand starts growing, it grows as a mass, but then is it fingers growing from the blob, or is it cells dying to form a hand? It's both. This is why you have bi-directionality. Just like back to the lightning bolt, right? The lightning isn't just striking down, it's also striking up. And the growth of the fungus is not just from point A to point B, it is also time symmetrically from point B to point A at the same time.
Right. Yeah, our bodies, like the cat, is both alive and dead at the same time.
Yeah, and that one is easier to understand, right? But that the future and the past are also entangled is weird.
Yeah, I know. Yeah, it's well. I'll tell you what's weird about that is though there is evidence in that in our genetic record, where I've seen some experiments where using certain microwave frequencies, they've been able to retroactively evolve fish and certain animals. Like they brought back a salmon that was a prehistoric salmon that lived like some 30,000-40,000 years ago. It's been dead for eons, right? But by microwaving modern salmon with a certain frequency, they're able to retroactively devolve these things into something that existed earlier, right? And they've also caused another experiment where I saw them change essentially ducks into chickens, or at least some sort of hybrid, without actually mingling the materials using microwave frequencies. Right?
Well, I think there's at least the potential of something being tied to biology.
Yeah.
I know.
Well, see, that tells me that. Well,
a lot of the things that we're talking about here is very fringe and very strange, and we could also start talking about the quantum nature of the brain and Penrose Hamerov's model and all of that stuff, or even the weird, whether there's a C pinch in DNA and whether that is what gives access to this harmonics through time, right?
I was going to say, I was trying to get to that, right? There is a Z pinch not only in DNA, but there's a Z pinch in every proton. Right? Well, that's where the magnetic field comes from.
And it's back to the singularity effect, right? The what is the horizon, the scale, like nature of galaxies, solar systems, planets, cells, organisms. How do these things self-referentiate? How do they relate to themselves on scale? Like how come the biological organism is able to have this almost conductor-like behavior where all the cells know faster than they can actually communicate in space, right?
Yeah.
What is it that governs that? Is there a little what is it, zircon crystal that gives you the atomic time, so it knows exactly when to start dividing and what type to actually differentiate into?
Well, see, that kind of tells me that before there's a discharge of anything, the entire system already knows.
And that takes us back to
Right.
How does it do that? It does
Right.
that because of its ambient environment and the fact that it is disconnected dependency-wise from time. It already knows what the result is before it starts doing it.
Yeah. Yeah. So like you said before, like we're seeing the dead side of the body, which is similar to an already discharged energy it's now been dissipated. So it's only when we see it collapse is when we see it, right? So when the wave function actually does collapse, that's when it appears, right? So we're seeing the death of it. Right? Yeah.
And the illusion, I think, the illusion of the arrow of time comes from the fact that when you have all these entanglements through time, then it looks like it's just a finger growing in one direction. You're not seeing, you're not noticing the fact that to do that, there has to be some cells dying in the negative space.
Yeah.
And it's the same when you see how solar systems are formed or galaxies are formed. Well, you're only thinking about the branching in the positive space. You're not thinking that there is also the opposite happening in all the negative space. When a tree grows, sure, you have all this branching and you have the roots doing the same, but you might as well look at the negative space and that as a development as well. It's going to be the same result. So you have both.
Yeah. Well, there's a mold. There's basically a mold, like a mold the tree is in, right? It's actually already in it. Right?
Yeah, the space is the mold, right? So right. It ends up branching, but it is because of the result of the canopy is why the branching in the generation before was the way it was.
It's limited. Yeah, exactly. Yeah.
About just nitpicking a little piece here, looking at these galaxies in the dark ages and the fact that they look like our galaxies. And what I find interesting is that we've taken steps back in that the Big Bang sort of thought they had the idea of how galaxies evolve, how they became small galaxies and then evolving into larger galaxies. And what they find by looking at these galaxies is they're smooth, they're uninterrupted, which suggests that they are like the galaxies around here. So we're sort of like back to square one, very much in how do galaxies evolve. We don't really have a good idea of that anymore.
But this is most likely linked and related back to what we already talked about, the composition. So the initial state.
I like to take us back to what we've already talked about.
Well, but if you think about it, it's if you create your dough in a certain way, you're going to get a certain type of bread, right? And it's slightly similar with this. Again, the problem is that it's self-referential, so it feeds back on itself. But if the local environment is of a certain composition, then it will give rise to a certain type and family of galaxies and stars. It's the same thing all the way down. It's the initial composites that will tell you what type of star you get or what type of planet you can get, but it's not locked in. This is where I disagree with current science, that they don't seem to realize that it is also evolution. They also evolve into something else.
Yeah, I mean, one of the problems with science is, and I've used this sort of example many times, is, the expert who knows more and more about less and less, and we divide the cake into the various disciplines, biology, cosmology and stuff. While I think that it's really important, and I sort of only have the skill set to see the overview as, like looking at behavior of different things in totally different environments that are producing the same effect, I do doff my hat to the individuals, the scientists out there who are condemned to know more and more about less and less, because that's part of what you need to make that incremental progress. I doubt very much if we're going to at least in our lifetime, see this moment where nirvana takes place and everything sort of fits together and yeah, we got it. It may occur, but I'm just not seeing that right now. And I think that the clumsy sort of objectivism by observation is still very much, and the minutia of it and the boring collecting of data of it is really, really important still. And we can't sort of throw that baby out with the bathwater.
I think the data is, we definitely have to have the data. I think it's also what's important there is to, maybe the lens of insight, what Jake was saying about the bifurcation, right? When this bifurcation is happening with information, whether it's lightning or bacteria or electricity or DNA splitting during, sexual reproduction, right? That bifurcation of that information allows for a non-linear propagation. Like horizontal information can jump generations, right, so to speak, right? So that basically throws evolution out the window. So Darwin is gone, Einstein is gone, like all of the foundations of the entire mainstream science is gone. Like it's been washed out, and we need to start again.
The principles are the same, but the foundation is gone. It's loosening science up to see more actual truths instead of having blinders on, right? And I think we might actually reach a point where, at least to someone like us, it will feel like science has been completely renewed and is really starting to answer some of the big questions. I think the risk is that, and it's actually something that I had almost wished that we were going to talk about today. The risk is when science falls into the pits of religious, pseudo-religious, faith-based things like transhumanism. If you think about it, at least to me, I feel like the current direction of fusion, it's transhumanist. It is not based on fact. It is not based on science. Of course, it's impressive engineering, but the principle is based on fantasy. It's like trying to build big sensors to measure your brain and then try to upload the image into a big simulation system and then claim that I've just downloaded Stephen. Like, okay, fine, let's play that's what's happening, but it's not.
Yeah,
really
snake oil. It's peddling. It's packaging and peddling a fixed set of ideas that, for better or worse, is something that's made believable to to people who are interested in the subject, but don't really have the time to follow it. So these packagings occur and they become profitable, and that's why you have things like the Big Bang, with all its little tinkerings that they do to keep it afloat. And I think that is one of the big pitfalls we have, and one of the greatest dangers of for our species. We went through 2,000 years going in a downward direction scientifically with geocentrism, which didn't have to happen, but it was one of those traps that we got ourselves into. And what we really need is more humans who are ready to be skeptical and not be ready to accept a set fixed a formula that which are basically just interpretations of data. I mean, you can interpret data in so many different ways. And I think that's one of the things we should keep open, and what's happening is we're closing that door. That's how you get the Big Bang. That's how you get the hydrogen fusion core theory of the sun. That's how you get, we're going to build a controlled fusion reactor, is we just start narrowing it down, and all the things that are going on outside are just sort of shut out. And I think that's one of the big problems for mankind and for our species' existence.
I think this is back to what Chris and I was pointing out in one of the episodes, that everything is also political, and we have to acknowledge that you can't sit there and say that science is not political, because it's always going to end up political, because the reality of human existence is tied into the basic needs of individuals. So as long as you have these rats in the maze, then the maze will be solved by rats. So
yeah, exactly. So long as it's being funded, so long as a rat experiment is being funded, there's going to be a Dr. Calhoun somewhere. Right?
And that's the
just
problem,
want to tell
right?
you guys a 5-minute warning. We can keep the conversation going, but I need to keep this thing.
Yeah, I know you're going to end the recording, but I think what I'm saying is that we need to start acknowledging and developing our way of thinking. I think there's a huge need for modern philosophers to solve the Gordian knot, right? Because you cannot disconnect our science from our understanding and belief. You can't get rid of the ghost of religion, because that is basically when humans start assuming things without actual deep knowledge or evidence, which is a requirement for being taught, because I have to assume that what you taught me is true without me having to test everything myself. There's just not enough time. So as a society, we need to start figuring out, how do we balance the problem between, basically between totalitarianism and democracy or anarchy, right? We have to find the perfect balance point, because otherwise it will just be like with the tokamak stuff, where a near faith-based scientific model and assumption has sold itself to a fantasy and dream that is then being funded, which means that the actual funding can't go anywhere else. So you're just hammering on in one direction, and nothing can progress.
Yeah,
the same as with your heliocentric problem, right?
What it comes down to is the altruism in science is a rare thing. I mean, a lot of people, like I'll use the controlled hydrogen fusion research as it stands today. I think 1/3 to 1/2 of those people are just going along to get along, and they're getting, it's filling their wallets. That's basically what drives it forward is, we got all these people to feed, got to go hit the government or whatever institution to get more money. But, it's sort of like self-perpetuating, and at the very lead of it, it's just going nowhere, and it's very destructive for our species, for mankind, to just squander such huge resources on something that even the people who are working on it are like skeptical about.
And this is why it comes back to, who was it that said that progress of humanity happens with one death generation after another.
Yeah.
Not moving forward until the old guard dies, because.
But the problem we have now, Jakob, is we've had the old guard die, and the young ones are just picking up where the old ones left off as far as fusion research, controlled fusion research goes. It's like there's been no one has come from the outside and there's been no effort of this groupthink to go to the outside and say, hey, look, guys, we're in real trouble here. We haven't done anything like extraordinary with this for over 50 years. maybe we should open the doors to the alchemists and the heretics out there in the world to see if there's some other way we can think about this. That's not happening. That's not
And
happening.
maybe we should start a GoFundMe for a fusion research and alchemy project or something.
Well, I think the problem to me comes back to politics, and I don't want to take us down that rabbit hole just on this these last 5 minutes. But when you think about it, the problem is if funding and publishing is vaulted and monopolized, and there is no equivalent of antitrust happening in science and academia, then we can't evolve. That's just the nature of the thing, because the establishment, the monopoly will be upheld because nothing else can reach the scale to compete with it, right? There is no one that can do a GoFundMe that can build a tokamak. Sorry, Chris, but that's just not going to happen. There's not enough interested parties out there that want to throw money at that scale. You couldn't even get a GoFundMe to pay for the electric bill for a tokamak, right? So the point is we need to start talking about academia, about publishing, about access to education, about actual funding of experiments and research needs to be, I'm going to call it anti-totalitarian, so anti-monopolistic, but also anti-capital. You cannot have these two systems functioning in that. It's just going to kill it in either one or the other direction.
I think itself right now too, with all all the good information is being hidden behind paywalls and stuff right in the journals, right? So I mean, you got to get rid of that, otherwise it won't progress.
I would, on that subject, I actually have some good news, which you probably have heard of already. But the White House requires immediate public access to all U.S. funded research papers by 2025. I think that's very cool, and that's something that's funny.
It's funny you bring this up, because isn't it weird that it is in 2025 that people are waking up to the fact that if it's the government, so you and me, paying for something, we should also have access. It's like, but the alternative, the fact that we have been existing in an alternative where governments pay for and fund research that is then vaulted into a paywall private enterprise, this makes no sense. That's like if the government pays to build roads and then it gives away the access to it to private companies that can then charge you to drive on said roads that you've just paid for.
After it goes through the Epstein Island filter, right? It has to go through the filter.
It's just ridiculous, right? That it is the and this is political. It is the socialism for the rich. It's literally just you pay twice and someone else gets all the profit.
Well, it also makes the king the largest welfare recipient on the planet. So
well, it creates these extreme monopolies that then feed back on itself, because then they just buy the power. But the point is, if I have paid for the road, if I have paid for the infrastructure, if I've paid for the internet cables, if I have paid for the research, I'm not supposed to pay for it again.
Right. Yeah, exactly. That, the truth should be free and self-evident, right? And if it is self-evident, then it shouldn't be hidden behind a paywall. Right?
And especially the lower the aggregate cost, the lower the actual reproducibility of information should be completely free, as long as when it's been paid for once, right? And
I could go into a 15-minute tirade about this, but I think we'll leave that until next week, at least as far as this video is concerned. And we'll see whoever's out there next week. The three of us can continue. I'm just letting you know that it's time to wave goodbye